And don't like capitalization and, you know, usual. But what do I do on weekends? This is when it gets kind of really interesting. So I've always been interested in electronics. I was trained in electronics, and back in when I was 17 in 1998, 97, I built my first robot board. It was awful. It controlled by a cell phone that lasted a total of 4 hours. Pushed the 2 button and a light went on, pressed 3 button and a different light went on. It was just amazing. And ever since getting to Melbourne in 2012, I got into Arduinos. And they're these little computers that don't have a lot of CPU power, but you can do an awful lot with them. And if you see Steve at BuzzConf, you'll see what I mean. Well, he's coming up. So I got so obsessed that I needed a bigger project. So I dived back 20 years to when I hurt my wrist and was thinking I was going to have to replace my hand with a robotic one, back to when I decided to build robotic spiders, because a hand's a bit like a spider, you know. Spiders are really cool, and I'm so obsessed with it that everybody knows this now. Even my coffee people draw little spiders on my coffee cups. It's pretty cool. Spiders are cool. Spiders like Steve. Now Steve, I actually don't have my presenter notes, but Steve has 8 megahertz of CPU power. Is it megahertz? Kilohertz? It's very little anyway. He's got 8 kilobytes of RAM. He's got 250,000th the processing power and memory of his remote control, which is an Android device. There we go, cool. The version that you see up here, the reason I need this is because it's very specific numbers. The version that you see up on the screen is version 27, which plays an interesting role at the very end when I'm talking about my rapid prototyping, but I've completely rebuilt him 27 times. He's been in production for 2 years. He doesn't really do a lot. He's not very bright, but he's finished. I've got 8 other models to build. You know, he's finished. He's in about a 0.8 meter leg span, and he's about 2 kilos. Naturally, he's my favorite. He's my first child. Other spiders that are cool is Yorick. Now, I've got a video of him that I can show people a bit later. He's terrifyingly awesome. He's about 10 kilos, and he's at iteration 7. And as time went on through the development of Steve, my skill level went up somewhat, and I was able to achieve things faster, and even though he's 100 times harder, he is much more advanced at version 7 than Steve is at version 27. He's also my favorite, even though he has a 1.5 meter leg span and he's terrifyingly beautiful. He's got a long way to go though. He's going to have neural networking and a lot of the car ideas that Andy was just talking about before, being able to understand a room, to track down his prey, targets. Moving on. Friends. Thanks, Ben. Now, there's 3 really big things that have happened since I started electronics in 97, and I had like one of those telephone batteries. Andy, remember those? They're about as round as my forearm, maybe a little bit less. They're about this high, and they're about 3 volts, and they ran old telephones. They were terrible. That's how we used to power it. Now, we can get the same power as a battery that's as big as my arm, and one that's the size of my thumb. Thank you, Android and iPhone. Essentially, the bigger the demand for computers running on batteries, the better the batteries got. Now the next one was CPUs. So Intel, actually about 6 to 10 years ago, realized that they couldn't continually make the clock speed of CPUs faster. They realized that they actually got to a point where it stopped getting better. And it started to, fail and not work properly when you get beyond about 3 or 4 gigahertz. So what they've started to do is they've started making their CPUs use less power for every instruction. And that's spawned an entire field of ARM CPUs that use very little power and are extremely powerful, and little things like Arduinos. Now the biggest thing about that's enabled me to do this has actually been 3D printing. So if you imagine a 1.5 meter spider has some pretty big long legs, and if I was to carve for that out of aluminium, which I actually have the skill and experience to do, it would cost me tens and tens of thousands of dollars, and I wouldn't be able to fit it in my Collingwood apartment. And my girlfriend would never be near it because they're so loud and they smell funny when they're burning stuff. 3D printing, it enables me to make stuff at home in relative speed with relative noise, but nothing like a CNC mill. So, 3D printing is cool. I've got 6 of them. I don't have a problem. My girlfriend isn't here. She won't confirm that. Moving on. 5 of them are FDM printers. Now, that means fused deposition molding, which is way easier to say than the next one. Essentially, it's a bit like a hot glue gun on an X and Y axis, and it draws a picture, and then it moves up a little bit and draws another picture. And that's all that they do. But they do it so accurately that you can't see, well, you can if you look really close, but they're feasibly what you designed or have downloaded from Thingiverse to print. Essentially, after an absolute myriad and ballet of motors whirring and lights flashing and little bits of plastic falling off the side, and you end up with what you wanted to print. Now, the good thing about them is they're really cheap. So you can get an FDM printer, you probably wouldn't want it, but you can get one for about 200 bucks. You can get one for 400 that you would want. The materials are really cheap. It's $35 a kilo, and to give you an idea, the 10 kilo robotic spider that will take over the world, teach us things, he is 3 kilos of plastic. Out of billet aluminium, that would be several thousand, just in the material alone. They're relatively easy to use, especially in the 3D printing sphere, compared to other 3D printers. They're way easier to use. And yeah, there's lots of different kinds of materials. The downside is they're really, really loud. Really loud. Mine, I got one of the quieter ones. It's called a Wombat, made by one of our sponsors, Arurum. I always say that wrong. It's not too loud, but I still have the door closed, and another door closed, and another door closed to keep it from keeping me awake at night. They're very slow. They take forever to print, and when they do bind up and catch your part and throw it into the side of the printer, they're actually made with quite dumb CPUs. They don't know that they've bound themselves up, so you end up replacing quite a few parts when they do that. But if you tune them right, they're absolutely fine. I haven't had to fix my Wombat yet, and I've had it for 2.5 years. Right, so the next one is SLA printers. Now, I've only got one of these, unfortunately. They are a really cool idea. These are actually the oldest type of printer. They were invented in the late 70s, except they're very different now. They used to use an OHP. You remember those people who are over 30? OHPs in school, they used to have a sheet of clearish plastic with something drawn on it, project on a wall. Yeah, they use data projectors now. Anyway, so the data projectors and the SLAs are way, way accurate. So I can print something that's accurate down to, I think it's 40 micron. So that's, what's that, 40,000th of a millimeter. No. Yeah, it's about that, yeah. Which is probably more logically said a 250th of a millimeter. No, that's 4. Sorry, a 25th of a millimeter. In all axes, which is really accurate. It's feasibly more than you can see. They basically work by projecting onto a thin film of liquid and then moving whatever you've then converted to solid plastic with the light, moving it up or down depending on what type of printer it is, and then doing it again. So they work in layers. Now, the cool thing is they're very fast and they're very quiet. Essentially, all you can hear is the fan on the projector. And the one in mine's actually fairly loud, but it's still half as loud as the quietest FDM printer I've ever heard. They're extremely accurate, like I was saying, down to a 25th of a millimeter, which is crazy. And some of the really expensive ones with stupidly expensive liquids are even more accurate. The dentists are printing whole teeth to demonstrate to people, or whole mouths, sorry, to demonstrate people what their smile will look like after their dental surgery. They've also got very simple mechanics. All they're really doing is moving a layer thing up and down. So there's a lot less to break and a lot less to fix. The downside is they're really expensive. So my Gizzy Pro, which is a very accurate SLA printer, is the same price if I was to buy the other 5 printers twice. Yeah, it's about $7,000, which is quite painful. The limited material types, there's only a certain amount of materials that can actually handle having their properties changed by ultraviolet light in a positive way. Most things tend to get a bit weird. The liquid is pretty volatile and it kind of smells bad. My supplier tells me that they'll digest a GoPro in 4 hours. When it's solid, however, and it's been cured and looked after and cleaned and baked in UV masked sunlight, stuff like that, they're actually non-toxic. That's what I was going to make the drinking horns out of. Oh, yeah. I probably shouldn't have said that. Now, I have precisely 0 sintering machines, which is a real tragedy because they use lasers. Now, they're amazing. There's 2 kinds. One of them, which is kind of the less interesting one, takes a layer of powder of some kind of material. The cheaper ones, you know, $10,000 to $50,000, will do that with nylon dust. The more expensive ones, you know, $1 million or so, will do that with titanium dust. And it'll burn a drawing, and then it'll blow dust on top of it, make it flat, and burn another drawing on top. And ultimately what you end up with is a lot of solid pieces with dust in between. You shake the dust out and you've got a beautiful titanium spider leg. Yeah, they're pretty cool, but they're stupidly expensive. So ones that will print metal are in the order of 900,000 to 1.2 mil if you want a good one. And they've got lasers in them that are federally regulated, and you'll be on a list for the rest of your life because they can cut planes out of the air, almost. They can damage anything. They're amazing. Normally a carbon dioxide laser, but not the really, really hot ones. They use fiber lasers. I can't remember what they're made of. Unfortunately, I'll never own one of those unless somebody wants to buy me one. Now, there's other really interesting things that they're calling 3D printing, and I'm starting to get a bit weirded out by this term 3D printing, because some dude's got a crane with a concrete mixer, and the crane moves the nozzle around and makes houses. And yeah, it's kind of like an FDM printer in the way that it moves, but is it really printing? But it'll make a house in a couple of days instead of several weeks. And the machine will just work day in, day out, all night, just do the same thing all day, make the house. There's paperjet printers at Officeworks. You can actually go in and see these things. I'm not sure if you can see them actually printing, but you can go in and they'll scan you. As you can see on the top right there's 3 sizes of some guy. They'll print you in color.